29th. So hello, was my voice audible earlier? I don't know. So I'll just repeat. This is welcome to all of you for this uh, weekend session. And as you know that this is an online platform for structural engineers to interact with us and ask their doubts or difficulties that they may have related to any steel design or RCC design project or any other conceptual difficulty or any construction site issues. So every weekend we conduct this session, and this is the 29th such session of this course, of this session, 29th such session. So as we always do, we'll begin by taking the queries that have been asked in the Google form, and then we will take up the queries from live comments, and if there are any queries in the email, that also we will take. So I'll start with the question asked by engineer Rishabh Thakre. He's from Mumbai and he's a working professional. I'll just put his question over here. So he had asked this question in the last session. In continuation to that, he is asking over here, as you explained in the last session, for expansion joints in buildings having plan length more than 100 meters, expansion width will be this. So deflection will be taken for earthquake force only or for seismic. No, it will not matter. You take it for earthquake force only. That's okay. You take it for earthquake force. No need to take it for a load combination like dead load plus earthquake or dead plus something. I think it's good enough to take only for the earthquake force. And see, horizontal deflections will not increase even if you combine the dead load case with the earthquake loads, right? Horizontal deflections are not going to increase anyway. So it's okay to take only the earthquake load case instead of taking the load combination in it. All right. So this was Rishabh Thakre asking his question. Then we have next question is from Parikshit Parikshit S from Bengaluru, and he is a postgraduate student. I want to do my MTech project on steel bridges. Can you please guide me? No, guide me with what? You have to be more specific. Guide me means guidance. In what aspect do you need guidance? That you have to clarify. It's not clear from the question. On which aspect of your MTech project thesis or MTech project you want guidance? So he wants to do MTech project on steel bridges. Can you guide me? So guide me with what is my question? Guide me with. So let him put his additional query or additional clarification. As of now, I'm not quite clear what he wants to ask. Okay, so what else do we have? So we don't have any other question in the Google form. We don't have any other question in the Google form as of now. So now what I will do, let me just take queries that have been asked in the live chat, and let me just put this query over here. So Mr. Rohit Sangani is asking how to design lacing uh, between columns in StatPro. Okay, so if you have come up with a built-up section, suppose in StatPro you want to provide a built-up section. This is a common doubt that people have, that what to do with those lacings, or suppose you have come up with baton system, what to do with that. That is a common query. So in plan view, let's say this is your column, and in the elevational view, uh, these are my flange widths, and then so number one thing you need to understand that, let's say these are my lacings. Are these lacings at every cross section in the column? Tell me. Is this lacing there at every cross section along the length? So answer is no. This lacing is not there at every cross section along the length. What I mean by the question is that suppose I cut a section over here, what will be the section looking like? So there is no lacing at this section, right? If you cut a section over here, then there is lacing on one side, let's say over here. If I cut a section over here, then there is a lacing on the this side. So my point is that if you want to make a column, built up column in stat, what many people tend to commit a mistake, that they will go to section wizard, and then they will make a section like this in section wizard. So maybe they will add a channel over here, they will add another channel over here, and then what they will do, they will provide also a lacing cross section like this, and then this property they import to stat. Now what is the uh, wrong thing in this? What is the problem with this? So the problem, as I think you have understood, that if you create this type of section in section wizard and then import it to stat, what stat will make out of this is that this type of lacing section is available at all the cross sections throughout the length. Is that clear? And that is not the case. That is not the case. So if that is not the case, you should not do like this. Therefore, this is incorrect way of doing it. Do not do like this. Do not do like this. And therefore, what needs to be done, that let's say you are going with a built up column, you just make this built up, or you just make this cross section in stat wizard, section wizard, without any lacing batten plates. You take it to stat, you take this to stat, design the column, and for lacing do the design separately. Is this clear? So do the lacing design separately. Am I clear with what I have explained? So do not do the lacing design in stat, do the lacing design separately, and just make a built up property. You can make it directly in the section properties available in stat, or you can take it from the section wizard. And the lacing part or the batten, if you are providing, do those calculations separately. Do not model this type of lacing in the section wizard. That is wrong. Another way can be Another way can be that, see, in the earlier case, what we were doing, basically, I was only modeling it as a single line element. In StatPro, this was a single line element that I was modeling, and to this line element, I was giving this built-up property. Now, another way can be of modeling. What can be the other way? That you actually model two lines in StatPro. Do you get it? You actually model two lines in StatPro, which will represent the two built-up channels or built up members, and then you actually model these types of lacing elements by individual line elements. Is it clear? So if you are doing that, then these are my lacings modeled as line elements. So now what I have done, I have created two separate lines which are representing my column built up members, and then I am modeling the lacings also. I'm creating nodes, I'm modeling these line elements. So this is what you can do, but of course this is quite time consuming. And if let's say you want to change some lacing arrangement, or if some geometrical changes have to be made, it also will consume a lot of time. So I will not recommend you to do this. So the easiest way to tackle this situation is what I just explained, that you make a built up property in section wizard and just import that property to stat, or even in section properties you can make a built up cross section, and the lacing design, do it separately. So I hope this is clear now. Okay, so this was engineer Rohit Sangani asking his question. Then Mr. Mohammad Danish is asking, can you please explain the value of Kz for columns for different condition, how stiffness of beams are taken in consideration at different levels, and we get the value of Kz. So you are asking in Stat Pro with respect to Stat Pro. So for this, if you are asking this for RCC design, you may go to the for the process of calculation, how the stiffness of beam is taken into consideration. If you are asking for RCC, you can go to the Appendix E, I think, Appendix E, which will show you the calculations for the Wood's curve. I mean, the effective length calculations based on Wood's curve. So for KZ calculations, you can go to just have a look at the Appendix E values, that how those beta 1, beta 2 is calculated. Okay, the stiffness ratios are calculated, and then on the basis of that, for RCC at least, it will also find out a stability index, and then on the basis of that, as per sway or non-sway columns, it will calculate that K value. So you can go to the Appendix E of IS 456 for details. Similarly, in steel design also, there is an appendix. I'm not remembering the name. I think it is Appendix F or G something. So similarly for steel design also, you can go to the respective appendix and check what's happening. STAT is unable to calculate these effective length factors on its own. So STAT will not calculate the sway factors on its own. So you will have to do these calculations, sway calculations you need to do. If you are using ETABS is able to do these things on its own. Okay. So for details, just go through these two appendix first, and then you will get a sense of what we need to what details we need to give to the software. Okay. Yes. Anything else? So we don't have any other query on. There is no query in the Google form also, and there is no query in the email also. Okay, there is one, but no supporting question has been put. Any other question someone wants to ask? I'm just checking if we have any other doubts. This question was asked by Engineer Anshuman Adhikari from Guwahati. So let me just see what he has asked. So he has asked this doubt. Engineer Anshuman Adhikari, he has asked this doubt: how to design a three-plate section that bears on a concrete column. I want the connection to be a pin support. No, so design means you want to have the design of. First thing that is not clear is, do you want? So he has made this. This is the top flange. He has shared this image, and then this is the web, and then this will be the bottom flange, and it is sort of resting on a RCC pedestal over here. So his query is, how do we design a three-plate section that bears on a concrete column? I want the connection to be a pin support. So what is not clear is that, does he want to know how to design the connection or the column or the steel beam? That I'm not sure about it. I'll just answer what you can do, that if you want to give a pin support, one of the options is to give a pin like support, So pin like support means which will not be actual pin, but it will not resist lot of movements. It will not be able to resist lot of beam movements. So if that is what you want to do, then one of the options is that you provide the bolts, let's say very close to each other like this. So in plan view, how it will look like, in plan view, this is my RCC pedestal, and then this is my steel beam in the plan view. This is the bottom flange, let's say, and web. So then what you will do, you will provide a base plate over here, and the bolts that you will provide, these bolts will be very close to each other, let's say, just to resist tension if there is any, or just to provide stability, and you will not provide any stiffeners, etc. So if you do this, this can behave as a pin like support, and then you can do the calculations mainly for the tension uplift. All the compression forces anyway will be transferred through bearing. So in this way you can provide this type of a connection and assume it to behave like a pin like assembly. If you want to have an actual pin, so for actual pin, then you will require a more elaborate arrangement. You will, let's say, if I were to show you in the elevational view, this is your beam, this is your beam in front view, and let's say this is your RCC pedestal below. So if you want to have an actual pin, then you will require a more elaborate arrangement. Maybe you have to provide a plate over here, and then that plate will have something, some another additional plate like this. Then to that additional plate, you can have another plate like this, and then this plate in turn will rest on your RCC pedestal. No, I'll need one more plate like this, and then there will be actual pin provided. There will be an actual pin provided, making holes in this. So this can be an actual pin like connection. Okay, but this is a more elaborate arrangement. So you can think of this also. Then for the design, what do you need to do? So for designing this, we were discussing this in the earlier session also. You can refer to the Ask AuxEn Anything session number 28, where we were discussing this pin like assembly. I think I will have it in over here also, one note. I had drawn that assembly last time, I remember. So these were the questions asked in the last session. Somewhere I had drawn it. I will just see if I am able to find it out. In one of the sessions, I had drawn that actual pin type assembly. So if you make that pin type assembly, if you want an actual pin, this is how you do it. And then for the design, if you are asking, design means mainly you will have to check these webs for bearing, and you will have to check this web for crippling. You will have to check this web for buckling. Why so? Because there is a, at the react connection level, there will be a reaction transferred from this RCC pedestal, and you will have to check this web due to this reaction transfer. So you will have to check your web, and you will also have to check your flange in local buckling, web in crippling, buckling, and bearing. So all these checks you will have to make. So I think this is what you wanted to ask. And this was Engineer Anshuman Adhikari asking his question. Okay, so anything else do we have? Any other question do we have? Because we have taken up all the questions on the Google form and in the email also. Engineer Balaji from Chennai, he is asking this So he has not asked anything. He has just shared one image. I don't know what his question is. He has just shared this image. Engineer Balaji from Chennai. So no question is attached with it. So unable to answer. Yes. Anything else do we have? Okay. Anyone wants to make any comment or any observation or whatever? Yes. Good morning, Engineer Padma Vijayan. So I think there is no further query or question. I'll just wait for a couple of minutes. If we have another queries or questions, we'll take up. Otherwise, we will end the session. Yes, Engineer Salman Roj from Palanpur, if I remember correctly. Engineer Salman Roj from Palanpur. He is asking how to design boundary element for lift. So there's, I mean, it's not different. Boundary element for lift walls is nothing different from your normal boundary elements. So if this is your, let's say, wall, seat type wall, then you can have boundary elements over here. Okay. And as I have, we have discussed this point before also. If you have made this type of wall in ETABS, let's say, you assign, first of all, you assign separate peer labels to them, analyze it, design it. Once you will analyze it, then you will get the peer forces. So from those peer forces, individual peer forces, you can work out the boundary element sizes, and you can work out the boundary element reinforcement details. For that, you can follow the IS 13920 2016. It has the calculations and the necessary requirements for boundary elements. So you model a siege type wall or whatever you have, whatever shape of wall you have. Suppose you have a combined lift core. That means if you have a core walls like this, two C's, let's say, then usually we will provide our boundary elements in these regions like this, like this. Here you can generally, in our projects, we provide it like this. Okay. You may do it like this, or you may just provide a normal rectangle. And here also, in this wall also, you can have a L type boundary element also provided, no harm in it. And then while analyzing, you just assign different peer labels. So let's say this is P2, this is P3, this is P4, P5, different peer labels in ETABS. Run the analysis, get the peer forces. Once you get the peer forces, then you can find out the boundary element dimensions and reinforcement details. Do not follow ETABS for boundary element design, because ETABS does not consider the moment capacity of this web portion of the shear wall. So it ends up giving very high reinforcement requirements. So do not follow the calculations that ETABS does. You try to do it manually or prepare some Excel sheet based on the IS 13920 calculations. Okay. Yes. So do not follow ETABS for this, for boundary element design. You may use manual calculations, or even RCDC does the job well. If you are using RCDC as a tool for post processing and reinforcement calculations, you can follow RCDC also, or you can use RCDC also. So RCDC also does a good job, and it does calculate the boundary element values quite well. Okay, so this was his question, Engineer Salman. Do we have any other question? No. Yes, any other question or comment? So most of the live audience that have joined, I what I understand is you people are practicing engineers, right? So which type of structures do you mostly do? The people who are joining live, which type of structures do you mostly do? RCC, steel, buildings, bridges, infrastructure. What type of or residential buildings or commercial or industrial? What type of our what type of structures do the people in live audience do usually? There are no questions. There are no answers. Sorry to this. Mr. Mohammad Danish is saying in steel structures in the industrial sector. Very good. Very good. Engineer Salman Roj is asking for retaining wall design. STAD is better or ETABS? I will say that ETABS is better because of the outputs that ETABS is able to give, and even for liquid retaining structures or any structures which involve walls, ETABS does a better job than STAD. That is my opinion because number one, the ease of modeling. In ETABS, it is easy to model these wall-like geometries, and you may have different plan shapes also. For example, if your building plan is like this and you want to make a retaining wall or basement wall all around it, and your plan shape is like this, it is very easy to model these types of shapes in plan. It is very easy to model these types of walls in ETABS because there is that extrude line to area option. There is an extrude line to area option available in ETABS. I don't know if you're aware of it. So with that option, you get a lot of ease in modeling these wall type structures. Load application in ETABS is also relatively simple, and then the outputs that you get that are also better in ETABS because ETABS will give you all the shear outputs. So it will give you the V13, V23 shear. It will give you the moments, and then it will also give you the axial forces integrated by assigning peer labels. So looking at all those things, in my opinion, ETABS is a better software than STAD for these types of structures. In fact, we have done an entire course on liquid retaining structures, and in that course, we had used ETABS instead of STAD because of the ease that ETABS offers. We had used ETABS over there. So my opinion is ETABS is better. Mr. Prashant is informing that he is involved in steel structures, PEV structures. Very good. Okay. Any other question or query? So I think we stop then. We have no further doubts. Mr. Salman Roj is asking for applying pressure laterally, local direction force apply, or global direction, which is better. No, no, it is not better or worse. You can apply in, I mean, you can apply the forces as per global direction also, local direction also. It is just that you need to be careful. If you are applying it with respect to global direction, you will have to see the orientation of wall and accordingly apply. If you uh, want to apply in the local direction, then also you will have to be careful. So it's not about better or worse. You just have to be careful uh, while applying the loads, that in which direction you are applying. Okay. Mr. Mohammad Danish is asking, Engineer Mohammad Danish is asking, can you please give any reference for book with all steel connections and its details to follow for American codes with all well details considering the manufacturing and installation point of view? I am not sure. I am not aware at this point. For AISC based codes, uh, I have been following the manual, AISC manual, and the AISC solved examples. So I am not aware of any good books other than this. So I have been following the AISC design manual and the AISC solved examples that you have. You will get it from the internet also. So I have been following this. Other than that, at this point, I am not aware of any good book. Engineer Venkatesh Hari is asking, what are the main parameters we need to apply in STAT for steel design? So main parameters would be your uh, main parameters for steel design would be, let's say, your FYFU values, FYFU values, then all your effective length factors. Okay, then what else? If you are providing stiffeners, then TST, TSP. Right now, the names of factors that I'm giving are mainly with respect to Indian standard. So, yeah, this is what you can do. Then I think track 2 is a good command to have the detailed outputs from stat. So in the Indian code, I think these are the important the design parameters. In the American code, again, the effective length factors, the FYFU factors. In American code, you also have the torsion factors. So I think all those factors are some of the factors or some of the design parameters that you should be aware of and that you may have to apply to the software, to the model before analyzing it. Okay, right. Mr. Salman Roj is asking, for base slab design we need to use safe software. You can use the safe software, and if it's a base slab, then you can apply the subgrade modulus. You can apply the subgrade modulus to the base slab, and then you can analyze it and accordingly find out the reinforcements. Apply the subgrade modulus to your base slab, K value, and then analyze your slab and accordingly find out the reinforcements. Jay Patel is asking RCC structures. No, what about RCC? What is question over here? Question is not clear. Okay, any other question we have? Oh, you mean to say the stat parameters for RCC structures? So the stat parameters for RCC structures could be no, acha, no. Okay. Mr. Venkatesh is asking, how do we carry out the lifting analysis in stat? So I think he has been involved in some company which creates these container-like structures, and then he has to do their lifting analysis, that how it will behave once it is lifted by some hook while transportation and shipment, let's say. So he's asking how to carry out lifting analysis. So I don't think there is a direct option as such. You will have to, I guess, you will have to maybe put some members over here, maybe give them some cable property. Okay, and then you will have to see what sort of forces are getting transferred over here, and due to these what sort of forces are getting transferred to the frame, and then analyze it. But I'm not sure of any automated procedure. I don't think there is any automated procedure. You will have to work out some jugaad on your own and do the such things. Maybe in extreme cases where there are for very critical structures, maybe for this cable also you will have to give some. You will have to look into the geometric non-linearity of this cable. That this cable may elongate, and due to that elongation, maybe some different type of forces, get transferred to your main frame. So for very important or very heavy or very critical type of structures, you may have to check for the geometric non-linearity of the cable also. Otherwise, you will have to work some jugaad, because TAD or ETABs are not going to do any lifting analysis as such for you. So this is the best I can think about. Okay, Mr. Jay Patel is involved in designing of RCC structures. So, okay, good. All right. Anything else we have? So I think that's all for this session then. We will stop over here as there are no more queries. General steel structure, how the lifting will be done? Mr. Venkatesh is asking. What do you mean how the lifting will be done? How means? See, general steel structure, nobody is lifting the entire structure. Nobody is lifting the entire structure. They are lifting it piece by piece. And they are lifting it piece by piece and then transporting it to site. So there are small, you are transferring a column piece or a beam piece, okay, or a rafter piece. So you're not lifting the entire built structure as such. If you are going to have panels, let's say you are making a pedestrian bridge, and maybe your pedestrian bridge was like this, and let's say it had some truss like this, and what do you do, that you may have made this panel in the workshop, and now you just want to lift this panel, and then on site you will do the bolting. So this is your ready panel, and now you want to lift it and place it to site or place it over there. Then you may have to check that what points we are going to lift, and while lifting from those points you may have to check some reaction transfers or force transfers through those lifting points. But otherwise, uh, if you are going to transfer it piece by piece or transport it piece by piece, then you need to, there's no need as such for any additional hooks, or no, there is no additional need for any such detail. See, if you are just transferring or just lifting a rafter element, then what they do is they just wrap it around the wire rope, they'll just wrap it around and transport it. So unless you are transferring or transporting some built panels like this, there's no need for any other specific detail for lifting purposes. But if your structure demands so, of course you can provide it, but not generally required. Okay. So I think that's it then. We stop our session over here. Mr. Venkatesh is asking, is there any thumb rule to consider preliminary steel beam or column dimensions? No thumb rule as such is possible because of lot of variations that you can have with respect to material or with respect to the uh, dimensions that you are considering, that no such thumb rule is there. So don't rely on thumb rules for steel structures at least. Okay. So that's it then for this week. We will again meet you next weekend. In the meantime, as I have told you before, also you can keep putting your queries in the Google form. The Google form remains the same. The Google form remains the same throughout the week. You can keep putting your queries, and as you know, once every week we take them up during this live session. And if you want to connect with us, you can connect with us on WhatsApp, and I'm just putting the link to connect with us on WhatsApp over here in the live comments. Yeah, I have put it in the live comments. So you can click this link and connect with us on WhatsApp also. So I think that's all for this session then. Thank you. And now we will see you next weekend. So till then, have a good time.